welcome to Apocalypse Now, the podcast where we dive into some of the most devastating environmental disasters and discuss the solutions and technologies to prevent them from ever happening again. I'm Holly Stower. I am an environmental researcher who's worked with some big name companies to solve real world environmental challenges. And for this podcast, I have spent the last couple of weeks researching one of the worst disasters, which is the BP oil spill or the Deepwater Horizon disaster. I'd probably say one of the most well-known environmental disasters, especially of my generation. I remember writing a report at university on it, I think a couple of years after it happened, and it's kind of stuck with me since then. And so I was super curious to delve into exactly what happened and kind of what has happened since, especially from the technology perspective, which I'll look into for the next episode. But understanding exactly what went wrong is super fascinating and so tragic. So spoiler alert, it was due to corporate negligence, but not necessarily all down to BP. And I will say, I'll use interchangeably the BP oil spill, the Macondo wellhead leak, as well as the Deepwater Horizon. So this happened in 2010, and it was such a disaster that Lionsgate made a film about it in 2016, starring Mark Wahlberg and Kate Hudson. And it's actually a really good film, and I would recommend. It is accurate to what exactly happened, so I would recommend watching that. So today, yes, I am in Tulum in Mexico, where I've been working on something new and special, and I'm really looking forward to announcing that soon. And I'll post it on my socials when I do, kind of a merging of a lot of different projects, but still along the vein of the environment and nature especially. And so today is also Chinese New Year, and being a scientist but also a bit superstitious, and hey, I don't fully know how the world works, totally honouring this Chinese New Year, and one of the recommendations is not to wash your hair, so I'm rocking the slick back look today. Super excited about this year. These next two episodes will be the final two of this series of Apocalypse Now, before I pick it back up in a month, maybe 2 months, and talk about some other really good stories. Okay, so let's get into the BP oil spill. So let's go back to April 20th, 2010. Obama was the US president. The Icelandic volcano had just started to erupt, which ended up landing loads of flights across Europe. And Rihanna was number one in the charts with Rude Boy. On the 20th of April at 2 p.m, BP executives arrived at the Deepwater Horizon offshore oil rig in the Gulf of Mexico. The rig was well behind schedule due to challenging geological conditions, and in amongst some circles and amongst the well workers, it was known as the well. Operations were running about 46 days over time and 50 million over budget, and each day was costing roughly $1 million per day to operate. Maintenance was also a constant for rig workers. The rig hadn't been dry docked in the whole 9 years that it had been operational. And while industry standards recommend that this gets carried out every 5 years, ironically, that day, BP executives had flown onto the rig to commemorate the rig's 7-year safety record. But rig workers sensed ulterior motives, feeling intense pressure from executives to move quickly and speed up operations. That evening, rig worker Stephen Davis had finished his shift. He phoned his fiancée, he had dinner, and did a workout at the gym. He was in bed watching television, and then he heard the first bang, describing it as the biggest explosion he'd ever heard in his life. Stephen was flung 5 meters against a wall, and then the whole rig started shaking. He was plunged into darkness. Earlier that day, he'd spent most of his 12-hour shift welding the transporter platform for the blowout preventer. And we'll get into why the blowout preventer is super critical later. And as he went off shift that afternoon, he continued to hear loud hissing sounds as engineered work to relieve the pressure from the ocean floor. And this continued for 3 hours, which really surprised Stephen, as usually this job is immediate. So back to the evening, Stephen's plunged into darkness, and then the fumes were all consuming. Stephen says he could taste the fumes, describing it as a god-awful taste in his mouth, and he struggled to breathe as fire consumed all of the oxygen in the living quarters. Stephen managed to grab a life jacket, putting it over his shorts and his t-shirt, not managing to get any other clothes, and managed to put some trainers on. And then he started to make his way upstairs to the deck, to the lifeboats, as the walls of the rig started to implode and cave in. As he finally made it on the deck, he was faced with screaming workers sliding around in mud that was covered on the rig floor. And those workers were also looking for the lifeboats. And much of the rig was on fire. Stephen describes looking another worker in the eye as he just jumped off the rig, trying to escape what he describes as hell scenes. Stephen made it onto lifeboat 1, but it was an 18-meter drop to the ocean surface. The boat was overloaded, but luckily the boat didn't capsize, and the survivors made it to the support vessel, which was a couple of 100 meters away from the rig. From there, they literally watched parts of the rig melt, and other workers who had jumped into the water were being saved by rescue boats, helicopters, etc. While it took less than 50 minutes from Stephen to get from the rig to the supply vessel, it would be another 36 to 40 hours until they made it back to shore, and a total of 50 hours until he was allowed to sleep. As with many of these disasters caused by major corporations, the aftermath caused further trauma to the survivors or the victims of the disaster. And aside from those who required immediate hospital attention, who were airlifted to the hospital, you best believe the rig owner and operator Transoceans had their best interests front and foremost. On board the support ship, workers were denied access to the onboard satellite telephone to call family members to report in safe. And while there were more than enough supply boats and helicopters to take the men, and it was mostly men, to shore, they were kept there for 36 to 40 hours. And then, when the workers were finally on shore, the company had, ahead of time, set up portable toilets to carry out mandatory drug testing. Beaten down and exhausted, Transocean made the men sign a statement that declared that they hadn't been hurt and they hadn't witnessed an explosion at all. They told some of them that if they didn't sign, they couldn't leave. Sleep deprived and traumatized, Stephen signed this document. And after that, workers were crammed onto buses, given a sandwich, taken to a hotel, and finally able to call their families and rest. That day, 11 out of the 127 crew were killed. Many when the rig exploded, or many during after the explosion. I won't go into the deaths individually, but 17 others were seriously injured. After the initial explosion, the Deepwater Horizon rig sank, and that was when the environmental disaster began. For 87 days, an estimated 3.19 million barrels of oil leaked into the Gulf of Mexico. The oil which leaked from the well formed a slick which covered the surface of the ocean. This extended more than 150 square kilometers of the Gulf of Mexico and started to contaminate the fragile ecosystems on beaches, marshes, and estuaries in Louisiana starting from May. Then by June, oil and tar balls started to contaminate beaches in Mississippi, Alabama, Florida. And in total, an estimated 1,100 miles or 1,770 kilometers of shoreline was affected. Cleanup on these coastlines would continue for 4 years, with the last Coast Guard cleanup patrols ending in April 2026 in Louisiana. This had a dire impact on fishing and coastal communities, with fishing being banned in the Gulf of Mexico for fears of contamination, and the tourist industry taking an absolute nosedive. An estimated 8,000 to 12,000 people were temporarily unemployed in this area. So this was a monumental environmental disaster that had huge impact, not just for the people that were working on the rig, local communities, the coastal communities in that area, and then a huge resulting oil spill, which had a huge impact on the local environment that I will get to. But a teaser, they only cleaned up about 25% of the oil and 75% remained in the environment. So, how did this happen? Who are the key players? And who really can we blame for this disaster? Or is it just a disaster? So let's jump further back in time to 1998. The oil rig was built in 1998 by Hyundai Heavy Industries. It was built for R&B Falcon, which later became part of Transocean. The rig was erected and operational in 2001 and was operated by Transocean through its Swiss subsidiary, Triton Asset Leasing. The rig was leased to BP from 2001, which was renewed again and again by BP until the disaster sank the rig in 2010. So what does this rig look like? I'll try and post what this specific rig looks like, but yeah, offshore oil rigs are massive. So the drilling deck is almost as big as a football field. It's also almost 250 feet high. Below deck is the living quarters for up to 146 people, and the whole rig is kind of like a boat, but it can be moved between sites. It floats and moves. What you can't see is what's underwater. So it's the massive submerged structures under the water. So starting from the seafloor, you have the wellhead. This is the drilled entrance to where the oil and gas is or could be if it's an exploratory well. And above that is the blowout preventer. This is a critical safety device that will be critical in this disaster. And above this is approximately 1,500 meters or 5,000 feet of steel pipeline and cable to enable the oil and gas to be pumped up from the well, or heavy mud to be pumped down to prevent the oil and gas coming up. So the Deepwater Horizon rig was a floating semi-submersible rig, and like its namesake, designed to operate in deep waters. And the rig had been operational on multiple oil fields before the disaster, all in the Gulf of Mexico. And it's even described as lucky and one of the most powerful rigs in the world. So these previous operations were leased by other companies as well, including BHP, ExxonMobil. In February 2010, less than 2 months before the disaster, Transocean and BP began using the Deepwater Horizon to explore an exploratory well site called the Macondo Prospect. This was around 66 kilometers off the southeast coast of Louisiana, at a depth of approximately 1,500 meters. This site was owned by BP since 2009 and was jointly owned by BP, about 65%, another company called Anadarko Petroleum, who owned 25%, and MOEX Offshore, or MOEX Offshore, who owned about 10%. To explain a bit about the exploratory stage. So the exploratory stage is a critical stage in oil and gas production, where you do it so you can validate the commercial viability of that well. and really determine whether it will be profitable or not, or whether you should continue operations. But it is an essential stage. The stage also provides critical information to best inform the next steps of harvesting the oil and gas, such as geological data or reservoir properties. For the Deepwater Horizon in 2010, the exploratory stages of this operation were in its final stages of completion. So with the exploration stages marked as concluded, cement was placed at the base of the well. This was led by cement contractor Halliburton and was meant to create an impermeable hydraulic seal and basically prevent any oil from leaking. But this did not happen, as we know. No single failure caused the explosion, which killed 11 people. In fact, there was a series of compounding failures which led to the largest oil leak in history. So there are many different actors responsible for one or many of these 8 critical failures. So let's walk through the major 8, starting with the cement. So number 1, the cement. So this was contracted by cement contractor Halliburton, and after the exploration stages were concluded, it was meant to block the well, so it was poured to block the well, but it did not create that essential hydraulic seal. So the cement for this application is meant to be light and fluid enough to flow down to the bottom of the well before it sets. So it needs to travel 1,500 meters deep. And this is further complicated by how hot the well is. So it's hot and more likely to set quicker. So to achieve the best results, they mix the cement with nitrogen and create this nitrogen cement foam. So this needs to be tested to make sure that the cement has set properly and no oil or gas is leaking from this sealed wellhead. However, Schlumberger, who were the contractor appointed to assess the conditions of the cement, were actually sent home by BP the morning of the disaster, without running these critical tests to assess the structure of the cement. So the failure of the cement led to the barrier cracking and failing, allowing oil and gas to flow upwards through the rig. So what went wrong here? After the disaster, BP commissioned independent testing of the cement, which claimed that the nitrogen cement foam wasn't mixed appropriately, causing large bubbles, which grew and connected and formed large cracks, making the whole thing unstable. Another opinion from chemist Greg McCormack, director of the Petroleum Extension Service at the University of Texas, is uncertain that paints the complete picture. Greg explains that not only is it the mixing of those 2 constituents together, the nitrogen and the cement, but there is a second challenge, which is how you get the cement to the right place at the right time. And that's really down to how you conduct the job. And that job was done by Halliburton. There are also significant differences between what the design team originally proposed and what was actually implemented by the contractors of the rig, pointing to a whole bunch of shortcomings, but mostly also in the management and operating procedures of all the companies involved. That was number 1. Number 2, a quick one, mechanical valves failed. So the pipeline had 2 mechanical valves to stop the flow of oil and gas, and they both failed. So number 3, the pressure tests were misinterpreted. So what does that mean? So the day of the blowout, their crew is getting ready to shut down the well, meaning they will be replaced by a new crew and then they can go home. So this also means that the operations, which were pressured by those BP executives to speed up, can stop, and the project doesn't spend another day in the red. So the final test to enable this crew to go home is the pressure test. This is where the heavy mud is removed from the pipeline, which is stopping the oil and gas from leaking up. That's removed and is replaced by a lighter seawater. So with that heavy mud removed, they test to see if the pressure builds up. So if oil and gas is leaking, and that concrete seal isn't working, it will indicate that pressure has built up. Now, at the time, there are no standards for this test, and BP's instructions for this test was only 24 words long, if that sets some context. So when they did do this test, pressure did build up, and those in charge of drilling operations were very rightly worried. But the BP executives had a completely different idea of why the pressure was building up. And they kind of believed that the test went fine. But rig managers wanted to repeat the test. So by 8 p.m., they repeat the test. And somehow everyone agrees that the rig test has passed. So somewhat reassured that there isn't a leak, the crews remove even more of the heavy mud that was keeping the pressure of that oil and gas down. However, as we know, the first test was accurate and oil and gas was leaking into the pipeline. And that brings us to number 4, the blowout preventer. So we've talked about the blowout preventer a couple times. Let's go into it. So at the seabed, the Deepwater Horizon is fitted with a 400-ton blowout preventer. This is meant to shut the well down in an emergency, and it does that via several methods, some of which are autonomous and some of which are manual. The most extreme of these methods is to cut the pipe and seal it. This allows the rig to break free and sort of float away. However, this risks damaging lots of very expensive equipment, so it is considered the very last resort. So this is really dramatically, the manual part of it is operated by a big red button in the control room and on the bridge. This system is called the Emergency Disconnect System, or EDS, so I'll refer to it as EDS. The bridge is the control center on an oil rig, and this serves as sort of a central command center for navigation, positioning, and some emergency operations. There's also a control center in the engine room and the rig floor. So let's jump forward to 9:38 p.m. that day. Oil and gas starts leaking through the blowout preventer at the seabed. The automatic fail-safe device, which was actually 5 to 7 years overdue maintenance, had failed. And unfortunately, once oil and gas starts leaking through the blowout preventer, there's no stopping it. So the first people to be notified that this is happening are the rig workers on the rig floor. So mud and water starts to flow out of the valves at extremely high pressure, covering the deck with muddy, oily water. So a drill worker notices this and his training kicks in. So he seeks to prevent the flow, but is alone and is extremely high pressure. So as the rest of the crew are preoccupied, trying to pack up and leave the rig, a crane operator luckily notices the flow and alerts the rest of the crew. And that takes us to number 5, the overwhelmed separator. So during these types of failures, the crew are trained to do one of two things. 1, divert the mud and gas away from the rig and vent it through pipes over the side and into the sea. Number 2 is use a device called a separator. This is designed to separate small amounts of gas from mud. So in hindsight, the decision-making process of senior personnel operating the rig floor brings even more irony into what happened in this disaster. But they chose to use the separator. This is because it's typically preferred for smaller blowouts to avoid investigations with cleanups which follow oil spills. However, this was no small amount of mud and gas. So with such intense pressure, the separator was quickly overwhelmed, and with nowhere else to go, flammable gas starts engulfing the entire rig. And that brings us to number 6, the gas detection system. This system also failed, or was turned off. So the rig is fitted with a gas detection system designed to warn of fire, combustible gas, or toxic gas. Each condition has its own distinct alarm. So as combustible gas was filling the rig, The system should have triggered an alarm alerting everyone and automatically shut down ventilation systems to prevent the gas from reaching ignition sources such as the engines, whilst also cutting power to electrical equipment, which could also be another source of ignition. However, Transocean had disabled the system's automatic feature, converting it to manual mode to avoid crew members being woken up by false alarms, which had happened a couple times in the past. But crew members had also raised the enormous safety concerns of this decision, but these weren't taken seriously. So like Stephen Davis in the opening of this episode, crew members on the rig floor can taste and smell this gas. So they manually shut down 4 out of these 6 engines and the electrics close to the rig floor. But also at this point, there's no communication between the rig floor, the engine control room, or the bridge, whom ideally at this stage should trigger the emergency shutdown of the entire rig. But again, it is costly, it can damage equipment, so they want to wait for someone senior to make that call. But remember, 2 of the 6 engines on the rig are still on, engine 3 and engine 6. And these start to accelerate, making a really high-pitched sound. Then, all the electrics in the electric shop start to explode, as do the light bulbs, and the whole rig is plunged into darkness. So workers begin to run off the drill deck floor, down the stairs, and off the rig floor. Then, engine 3 explodes, which blows the doors off the electrics room. This door hits a worker in the head, and as he's regaining consciousness, he's then thrown another 30 feet into the air as the second engine explodes. Luckily, he makes it to the lifeboats, but unfortunately the continuing blasts killed 11 crew members, and 16 others were seriously injured. Seeking to raise the alarm for help and to help quell the blaze, rig operators rush to the bridge as it's the only control center left standing. They find the captain shouting at bridge officer for initiating the distress call. Joining crew members, they explain that the ship is gone, and the senior officer then gets onto the intercom and raises the emergency alarm, shouting, "Fire, fire, fire." So the next port of call is to initiate the emergency disconnect system, the EDS, the ultimate failsafe to prevent the rig from sinking and quell the flow of oil and gas. However, there is some delay as these officers want the most senior member of staff to give their tick of approval. So they wait for rig supervisor Jimmy Harrell, who is played by Kurt Russell in the Deepwater Horizon film, to approve triggering the EDS. So with blood pouring down his face from an injury in the blast, Jimmy arrived and immediately approved triggering the EDS. Now number 7, there's no battery for the blowout preventer. So the explosion destroyed the electrics that the crew was trying to use to trigger the EDS and to close the valves in the blowout preventer, set the rig free, and seal the well. However, the blowout preventer on the seafloor had its own automatic system as well, which should have shut off the well, preventing further spillage of oil and gas and this huge oil leak which ensued. But more equipment failure. One of these systems had a flat battery, and the other system's switch was malfunctioning. So the many methods to seal the well all failed, and not the crew, who bravely did try to initiate this EDS system. Next, firefighting teams make their way to the rig floor to try and fight the fire. But only one member of the team makes it, and faced with an entire rig on fire and what is described as an hellscape, the crew begins to evacuate. So escaping to lifeboats with some with empty seats still on board, but I mean, you are surrounded by this ball of fire. You don't know who survived, except... And there was a huge central crane above them that looked like it was which was melting, that looked like it was going to fall. One member of the crew risked their life to try and divert that and to stop to stop it falling on the crew members who were waiting for the lifeboats, and he unfortunately died in that process. But there is a delay in launching these lifeboats. They want to ensure that they save every person and aren't being rash in launching them, but while waiting, many jump. Many worried that as they went into the sea would get covered in oil and would burn. But luckily the water was calm and warm that day, and many were able to dodge the fire and swim to rescue ships. So when the lifeboats did launch, they didn't know how many people were on them, and unfortunately 9 people were left on the rig. These 9 people launched an emergency life raft, but unfortunately for Mike Williams, who was played by Mark Wahlberg in the Deepwater Horizon film, he missed the boat too. And so to escape the flames, he climbed up to the helipad and jumped 200 foot into the sea. Luckily, with only minor physical injuries, he was picked up by rescue boats. So after burning for more than a day, at 10:20 a.m. on the 22nd of April, the Deepwater Horizon oil rig sank. But the disaster doesn't end there. This is kind of where it begins. That morning, oil began leaking from the rig at a rate of 8,000 barrels a day. But I will come back to that. Finally, number 8 on the list of causes to the Deepwater Horizon oil rig sinking. And if not clear by now, the biggest failure is the lack of maintenance of this rig. So Transocean never performed the essential maintenance required by law and recommended by manufacturers, which was recommended every 3 to 5 years, meaning the blowout preventer was at least 5 years overdue for inspection. The Deepwater Horizon oil rig was highly productive and used for roughly 92% of its 9 years in operation. The other 7% was for when it was moving to an oil rig or for some maintenance. But it was never dry docked, so it was never taking it out of the water for inspection, which is recommended every 5 years. So all in all, this was a lethal example of corporate negligence for all workers involved. And this must have been incredibly traumatic for workers, families, local communities. Many suffered PTSD, and many would never work in this industry ever again. So on that vein, I want to quickly discuss the aftermath and potential mishandling by Transocean and BP, and what this meant for survivors of the disaster. So I covered earlier how Stephen Davis was kind of kept awake for 50 hours, forced to sign this document that said he never witnessed a disaster. And this sort of being seen as coercion, high pressure tactics, intimidation, etc. So after some digging, I found that there were more claims from survivors that they weren't able to speak to their families unless they signed this document. So most of these claims come from a Houston-based attorney. He was representing 10 Transocean's workers. His name is Tony Busby, and he notes that these documents are often used to discredit people to bring lawsuits to companies, so hence an intimidation tactic. So these allegations were strong enough to warrant launching a federal inquiry. So in May 2012, Senator Patty Murray formally requested documents from Transocean. And then the Transocean CEO denied coercion under oath. And ultimately, there's no neat resolution, at least publicly. So these claims are all filed under each individual litigation case from workers against Transocean and BP. So there's no court ruling on whether it is coercion or not. So it's up to you what you think and who and what you believe. So who is to blame? We've met a bunch of different actors on the Deepwater Horizon, from Transocean's head office, who may have neglected maintenance duties, the Transocean crew, who suffered the worst of the disaster, 9 of which lost their lives, the Schlumberger crew, who were also on board, 2 of which lost their lives, And then we've got Halliburton, who was contracted to pour the cement, which ultimately cracked and failed. And finally, we have BP, whose executives sent some of the Schlumberger crew home before they could do essential testing on the cement, and pressured the crew to ignore maintenance issues, to ignore pressure test warnings, and were the owners as well as the contractors of the well. Well, ultimately, a 2014 US federal judge ruled that cement contractor Halliburton bore just 3% of the blame for the disaster. They then assigned 30% to Transocean and the last 67% to BP. Hence, I think we could probably aptly refer to it as the BP oil spill. So BP pleaded guilty to 14 criminal charges tied to the disaster. They paid over $20 billion in penalties and settlements and were found grossly negligent by the same 2014 court case. For Transocean, they pled guilty to violating the Clean Water Act and paid about $40 million in criminal penalties, $1 billion in civil penalties, so in litigation, so lawsuits from workers, the victims' families, and local communities where the pollution reached. But I'll come back to the utility of that funding and if it was enough to cover damages in the next episode. So next I want to talk about the environmental impact of the spill. I'm running out of time and battery, so I will cover that in the next episode. So in summary, the rig was overworked, it wasn't looked after. Those on board, especially executives, made some pretty risky calls. Then everything broke, people died, and the whole rig went up in flames, ultimately sinking and spewing toxic oil into fragile ecosystems for 87 days. So I think we can all agree, an awful, awful disaster for people and planet, one which continues to this day. So in the next episode, we'll shift from disaster to solutions, from the apocalypse to the no. And I'll be looking into how the crews tasked with plugging the well were literally innovating live on how this can be plugged and why no one ever prepared for this, what's changed in policy since, and how solutions exist to prevent all of these systems failing in the first place, as well as solutions to clear up oil without making it 57% more toxic. So if you enjoyed this episode, let me know. Please follow it on Spotify or Apple Podcasts, or you can follow me on Instagram or TikTok at Apocalypse Nope. I'm Holly Stower. This is Apocalypse No. And remember, stopping the apocalypse starts with understanding where it begins.